All right, welcome back. AP Calculus. We are finishing up our lesson on section 3.1. We're finishing up the lesson on derivatives. And in this lesson, we're going to look at how to write equations of lines with the idea of the slope, with the idea of the derivative. So just to recap, in the previous lesson, we were looking at the definition of derivative and the idea of to find the slope at the tangent line. We can use that formula, the limit as h approaches 0, f of x plus h minus f of x all over h, and that will give us f prime of x, the derivative at a certain x value of that function. So today in this lesson, we're going to be looking at how to write some equations of lines. Just to review, with the idea, well, we're going to write equations of lines with the idea of calculus in mind. And so, you know, from algebra 1, slope-intercept form was y equals mx plus b, and point-slope form is y minus y1 is equal to m x minus x1. So those are two ways of writing equations of lines. I wanted to say for the calculus part, it's more common to see point-slope form, but then again on the AP exam, they could start off with point-slope form, they could put the answer as slope-intercept form, they could even put the answer as standard form, which is ax plus by equals c. Basically all the x's and y's are on one side of the equation, and so you have to be comfortable with all three actually, but one of the common equations that we're going to see in AP Calculus is point-slope form. Alright, so from the previous lesson, we're going to use, from the previous lesson, the previous video on 3.1, we were given the function as 3x minus x squared, and we had to find the derivative, and we did that using the limiting process, and we got that the derivative of f was 3 minus 2x. So that is our slope function. I'm gonna put that in quotations. So anywhere on the graph we can figure out what the slope is using our slope function, using our derivative, or I'm gonna say derivative. Alright, so in this example, we have an example for you. Write the equation of the tangent line to the curve f of x equals 3x minus x squared. So that's our function at the point 1, comma 2. So we want to write the equation of the tangent line. So in order to write the equation of a tangent line, well, first of all, let's break this down into parts that we know. We got to write the equation of a line. Okay, that's number one. Write the equation of a line. More specifically, we want to write the equation of the tangent line that passes through this point. So this is how we're going to break this down for you guys. To write the equation of a line, I'm going to use this formula. That's an equation of a line. You need three parts, three pieces for this to work. To write the equation, you need the slope, you need the x value, and you need the y value. That's how you're going to write the equation of a line. Well, we know what the x and y value is. You know x1 and y1. That's given to you right here. That's the coordinate, x1, y1. x1, y1. So the only thing that we need really is our slope, our derivative. So to find the derivative value where x is 1, right, you were going to use that coordinate at that particular point when x is 1, when the x value is 1. So you're going to take your function, your derivative function, and since we want to find the derivative at 1, plug in 1. And you're going to get 3 minus 2, which is 1. So now, ladies and gentlemen, we know what our derivative is. The derivative at x equals 1 is also 1. So if we were to write our answer now, your equation of a line, of a tangent line, is y minus y1, which is 2. The derivative is 1. X minus x1 is 1. So that's the equation of the tangent line. Now remember, even though that you're writing this in point-slope form, the AP exam could simplify this equation for you. What I mean by simplify is distribute out that 1 times x, 1 times 1, negative 1. So you get 1x minus 1. You can still simplify some more. Move that 2 to the right side by adding 2 on both sides. Adding 2 on both sides. So if I add 2 on both sides, 2 minus 1 is 1. So that's the answer, the equation of the tangent line. And just to maybe help you out a little bit in case you forgot what standard form looks like. So this is slope-intercept form. Slope-intercept form. This guy right here that we started with, that was point-slope form. And for standard form, we're going to take that same equation and we're just going to put the x on the left side. To move the x to the left, you just subtract x on both sides. So you get negative x plus y equals 1. In standard form, we want to put the x term first, then the y, because alphabetically x comes before y. But also in standard form, the leading term, the x, shouldn't be negative. So what that means is I'm going to multiply both the left side and the right side by negative 1. So I get x minus y equals negative 1. So that's just another way of writing the answer. This is called standard form. Alright, so there's 3 different ways: point-slope form, slope-intercept form, and standard form of writing an equation of a tangent line. Let's look at next example. Write the equation of the tangent line to that curve f of x equals x over x minus 2 at x equals 3. So we gotta find the tangent line. This word means derivative. Find the derivative function. Well, we know our function is f of x, so in order to find the derivative, we gotta use the limiting process. As h approaches 0, remember that formula, f of x plus h minus f of x all over h. So that was one particular formula that we could use to find the derivative. But remember, there was another formula that we could also use. Since we know the particular x value, which is this guy right here. Sorry, let me get a highlighter. Since you know your particular x value, you have another tool you could use, and that's this other formula, the alternate derivative formula. To find the derivative. In this case, you're given the x value, so you can find the derivative at 3 by using that alternate formula for finding the derivative. F of x is that x over x minus 2. F of c is really f of 3. Now, instead of writing f of 3 there, well, let's write it and then we'll simplify. X minus 3. Now we got to figure out what f of 3 is. So we know f of x is x over x minus 2. So f of 3, instead of x, it's 3 over 3 minus 2, which is 3 over 1. So we know the slope, we know the f value at 3 is 3. The f of 3. We know the y value at 3 is 3. kind of confusing because x is 3, and so it just so happens that the y value is also 3. Alright, so let's continue. So we have our limit as x approaches 3. So let me go ahead and fix this guy too, because this should have been 3. Alright, now we have x over x minus 2 minus f of 3. F of 3 is 3 over x minus 3. Now we're going to combine the fractions on top. Underneath the 3 there's an invisible 1, but in order to subtract fractions you need a common denominator. So I'm going to make that common denominator x minus 2. Now if I clean this up, I get the limit as x approaches 3. Now I have a common denominator, right? It's x minus 2. On the top part I have x. Now I'm gonna take care of this negative 3 right away. Negative 3 times x and negative 3 times negative 2. So negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. The denominator is x minus 3. I could put a 1 underneath that x minus 3, and since I have a double fraction, to get rid of the denominator fraction I can multiply by the reciprocal. That's how I would get rid of that double fraction. So these guys disappear. And I have the limit as x approaches 3. The top part is x minus 3x plus 6. The bottom is x minus 2 and x minus 3. Now I could combine these, the numerator, they're like these two terms. The x minus 3x, that's negative 2x. So I have limit negative 2x plus 6 and in the numerator, in the top part of the fraction, the numerator, I could factor out a 2. More specifically, I could factor out a negative 2. The common factor between 2 and 6 is 2, but the reason I'm gonna factor out a negative 2 is because that could have an x, just like the denominator part. There's an x on the denominator. There's actually, let me fix this. There's an x minus 2 and an x minus 3. The issue here is that x minus 3, because if I do plug and chug on that x minus 3 part, when x is 3, I'll get 0. I can't have 0 in the denominator. So sometimes when you're factoring the numerator and you want to cancel the denominator, your answer is kind of staring you in the face, and then it's highlighted in this case. So negative 2 times x is negative 2x, check. Negative 2 times negative 3 is positive 6, check. So these guys are going to cancel, and you could do plug and chug. Just plug and chug right now. Whatever's left over, just plug in the 3. And so 3 minus 2 is 1. 3 minus 2 is 1. And your answer is negative 2. That is your limit. Negative 2. The limit as x approaches 3 is negative 2. So all that work, and again, I'm showing you all the steps. So if you can skip steps, by all means do it. What that means is the derivative at 3 is negative 2. That was what we're trying to find, the derivative. Let's go back to our problem. Do you see how I wrote the derivative right there? That's what we're trying to find, the derivative at 3. So now We want to write the equation of the tangent line. How do you write the equation of a line? Y minus y1 and x minus x1. We already know what the derivative is at x equals 3. So we know the slope, the derivative. We know the x value that's 3, right? That was given to us. The only thing left to find is the y value. Well, you know the y value equation is f of x. So just plug in 3 into that function. And as a matter of fact, we did that already. Do you see it right here? Let me see. Get my highlighter. To find the y value, we plugged in a 3 into the function, and the y value was 3. So we're set to go. We know the y value also. Let's plug it in. So we have y minus the y value, which is 3, check, equals the derivative, and we found the derivative to be -2, check, -2, let's go back, derivative is -2, x minus x1, the x value was 3, check. Alright, so that's our equation of a line. Ladies and gentlemen, we are finished. Now the book, when you check your answers in the back of the book, they simplify a lot of these problems. So if you're trying to see if you got it right, you might have to simplify your work. So distribute the -2, move the 3 to the other side, -2x plus 9, and that is slope-intercept form. But on the AP exam, this would have been acceptable, right? It's an equation of a line. However, when you're doing your homework, I encourage you to simplify, practice your algebra skills. Don't let the algebra get in the way of you getting the right answer, and just make sure you're getting them right. All right, our next example. All right, I was just checking to make sure my recording is still there. I think it is. I hope it is. I hope I'm recording. Let's see if I can minimize this just to check my recording. Okay, I see the red lines. Alright. So in the next example, it says write the equation of the tangent line. We know what that is. Tangent line, we know that equation. To the curve f of x equals 2 rad x. So that's our function. And it's parallel to this other line. So I wanted to start off by just showing you a picture of what we're trying to do and then solve it. So it says write an equation of the tangent line that is parallel to the equation 2/3 x plus 1. So this is the equation right here in green. That's the equation 2/3 x plus 1. Has a y-intercept of 1. So there's 1 as my y-intercept. Y-intercept. And the slope is 2/3. So I go up 2. You count 2 spaces up. And you run 1, 2, 3. So there's my other dot. And that's how I drew that green line. So that's the y equation. Y equals 2/3 x plus 1. What I need to find out is the equation of a tangent line that's parallel to the green line. And I did that for you in purple. This purple is parallel to the green line. The purple line is parallel to the green line. Not only that, the purple line is also the tangent line because it crosses the graph, that crazy looking square root graph, at one point. So that purple line is your tangent line because it crosses the graph at one point. So I have to find the equation of that purple line. That's the goal. How do you find the equation of that purple line? Well, to find an equation of any line, you need an equation. Y minus y1. So that's our equation. We know that our equation has to have a parallel, has to be parallel. So for equations to be parallel, they need to have the same slope. So we know what the slope is. Easy, right? Parallel lines have same slope. rise over run, 2 over 3, 2 over 3. All right, now we just got to figure out what the x value is and what the y value is. Write an equation to the tangent line that is parallel to the curve. Okay, let me see in my directions if I'm missing an x value. Okay, so I don't give you the x value, so we're gonna have to figure out the x value, and that's what makes this problem a little bit more complicated. So we know the slope, right? We know the slope is 2/3. Well, we also know how to find the slope function. We know how to find the derivative. So let's start with that. How do we find the derivative? So we're gonna say, to find the slope, the derivative, the more times you write that formula, the more you'll remember how it looks like, how it goes. Alright, so our f of x plus h is the original function x, right? But wherever you see an x, you're gonna plug in an x plus h. So that's the f of x plus h guy. So let's write that down. It'll be 2 radical x plus h minus f of x. F of x was 2 rad x all over h. So here we go back to these square roots. Remember those square roots from chapter 2, the how to solve those square root problems? We got to multiply by the conjugate. So to multiply by the conjugate, basically those square root terms, keep them the same, but change the sign in the middle. So that minus will become plus, and you multiply that on top and on the bottom. Now, I'm gonna simplify the top part because that's where I started with the square roots. So I'm gonna simplify that top part. So in the numerator, remember that I really just need to multiply the first terms and the last terms. Every other term when you multiply this out are gonna get cancelled, so that's kind of like the trick. So 2 times 2 is 4. When I multiply the first terms, 2 times 2 is 4. Square root times square root cancels, and you just get x plus h. Now the triangle parts. The negative times a positive. I'll do this in blue so you guys can see. I'm multiplying those guys right there. So negative times a positive is negative. So negative 4 times x. The square roots cancel. The bottom, don't even touch that. Just put them together. You don't need to multiply that out because usually that could simplify out if you do plug and chug, or could cancel. So let's take care of the top part. So we could distribute the 4 into the 4x plus h, and you get 4x plus 4h minus 4x. You have an h on the bottom along with that square root. Now we could cancel the 4x minus 4x, so they go away. You still have a 4h on top, and by the way, that's a positive right there. Kind of got covered in. All right, you could cancel the h's. So you could cancel this h right here on top and this h on the bottom, and you're just left with 4 in the numerator. So you're left with 4 all over 2 rad x plus h plus 2 rad x. Now you could do plug and chug. Wherever you see a h, plug in a 0. And you have 2 rad x plus 2 rad x, which means there's 4 on the denominator. 4 rad x. the 4's could cancel, and you get 1 over radical x. So what does that mean? That's your derivative. F prime of x is 1 over rad x. That's your slope. But in the problem, you were given the slope, right? The slope was 2/3. So what we could do now is set the slope, the derivative, equal to the slope that the book gave you. I mean the notes, like in this example, what the notes are 2/3. The slope is 2/3. So since the slope is 2/3 and our derivative is 1 over rad x, the slope is also 1 over rad x. We can make them equal to each other. So let's do that. 1 over rad x. The slope is equal to the slope. And the reason I'm doing this is to solve for x. This is like a little trick to solve for x. Since they don't give you x, you can solve for it. Alright, so you cross multiply. 1 times 3. And 2 times radical x is 2 rad x. Divide both sides by 2. And lastly, to eliminate the square root, you square both sides. So you get x equals 9/4. Now we know what x is. It's kind of nice, huh? Now we figured out what x was. X is 9/4, so if you go back to your equation, where's our equation? We know what x is. So we know this guy. We know x1 is 9/4. So the last thing that we got to figure out, and maybe I should just write our answer so we know what our answers are. We know x is 9/4, so I'm gonna write that there. We know the slope is 2/3. So the last thing that I need is this guy. I gotta figure out what y is, what y1 is. So that's the question. How could I figure out what y1 is? Write the equation of the tangent line to the curve. So you know your function already. The function that's given to you is that f of x function. The function that you're working with is that blue graph, that blue line in the graph. That's your function. So if you want to find the y value, plug in x into that function. We know x is 9/4. We solved that earlier. So let's just plug it in. Let's plug in 9/4 into our function. So we know that our function is 2 rad x. And you know that x is 9/4 because we solved that earlier. So if we solve for this, the square root of 9 is 3. The square root of 4 is 2. And so your answer is 3, the y value. So if you go back to your little red equation right here, our y value was 3. So now we have all the parts to write the equation of a line that's parallel to the green line, and that'll give us the purple line, the purple line that you see in the graph. So the answer is y minus y1, which is the y value was 3. We got that just right now. The slope, the derivative, that they have to be parallel to each other. So we figured out that the derivative was 2/3. And x minus x1, we did a lot of work, but we figured out the x value was 9/4. Alright, so that's the equation of a line. Side note here, you should be able to simplify that. And so if I were to maybe do this very quickly for you guys, I could say 2/3 times x is 2/3 x. Multiplying fraction with fraction, you get negative 18 over 12. And we're going to simplify that as well. Negative 18 over 12 minus. You can move the 3 to the other side, so that becomes plus 3. 18 over 12, you could simplify that and want that by 6, so it becomes 3 halves. Plus 3. And if I were to have a common denominator, I get 6 minus 3. So this guy will become a 6, right? 6. Since I have a common denominator, I could subtract the numerators. 6 minus 3. And so my final answer in slope-intercept form would be y equals, let me erase this little piece right here, 2/3 x 6 minus 3 is 3, so plus 3 halves. So that would be our answer in slope-intercept form. Know that our answer in I'm getting these equations confused right now, sorry. Class is about to start at 10:50 with advisory, so I'm like point slope form. Okay, there you go. So our point slope form answer is this guy. Alright. Yeah, I'm trying to finish up the lesson here as I'm recording because my next class is about to start in 10 minutes. And there's quite a bit here. I don't know if I'll be able to finish this in 10 minutes. So I think I'm just going to stop right here. I'm going to make another video just to finish up the lesson. Thank you guys for checking in. And there'll be one more lesson to finish up 3.1. Let's move my recording feature. Thank you guys for checking in. Take care.